Hey guys, I'm recording this on my phone because Screencastify hates me, so I apologize for the bad video quality. I'm going to do my best to make it as good as possible. So I'm going to be doing number 8 from chapter 13 on the review guide, which is an equilibrium question, which says, consider the following reaction at equilibrium. Here is our system, right? And it says, Le Chatelier's principle predicts that adding O2 to the reaction container will, and we're given a whole bunch of options here, and we have to choose which one's correct, right? So I'm going to go through each option and say why it's wrong and why the correct one is correct, right? So A suggests that adding O2 to the reaction will decrease the partial pressure of CO2 at equilibrium, right? So something important to notice when you see this problem is notice that there's more moles on the product side than on the reactant side, right? And now we're adding more O2, right? So now we're even adding more moles to the product side, right? So this thing is definitely going to shift to the left, right? I mean, no doubt. So we're going to increase the moles of CO2, right? Which means that we're going to increase the partial pressure of CO2, right? More gas, more pressure, right? Common sense. So A, we know is wrong, right? It's the opposite of what it should be. B, decrease the value of the equilibrium constant. Well, we know the equilibrium constant is K, right? And K is only affected by temperature, and there's no temperature change happening, right? We're just adding a gas, so we know that one's not right. That's also why we can cross out D, right? And then the correct answer is C, right? But I want to explain E really quick. E suggests that adding O2 will increase the partial pressure of CO at equilibrium, right? This one it just is the most obvious one. That's not it, right? If we're adding more O2 to the side that already has more moles of gas, right? We've already established that this thing is definitely going to shift left, right? It's going to produce more moles of CO2, right? So in no way is it going to increase the partial pressure of CO. It's going to increase the partial pressure of CO2. So that one's just, if you don't understand that, I'm sorry. It's just, yeah. And then, oh gosh, you can't see that. Okay, yeah. So we know the correct answer is C, right? Kind of, we know it's right because we cross out all the other ones, and also it's the reason why we decided that A and E were both incorrect, right? And C says increasing or adding O2 will increase the partial pressure of CO2 at equilibrium, right? So we already have more moles, like this side already has more moles, right? And we're adding more moles to it, so it's definitely going to shift to the left. Like there is no doubt it's going to shift to the left. So that's how we knew to cross out all these other ones, right? That's the end of this problem, but something important to consider when you see these problems is notice that there is a delta H, right? And that could have played a role in this if we were asked about temperature, right? But we weren't. But, we have a negative delta H, which means that this is exothermic, right? Which also means that you could write a plus heat on this product side, right? And I guarantee you there's going to be one on the midterm, right, that says plus heat on the reactant side of the product side, right? And we have to treat heat just like a reactant or a product, right? You know, what happens when we take away a reactant or a product, right? It shifts equilibrium. That's the same thing with heat. So treat it just like a reactant or product. Treat it just like an O2 or a CO2, something like that, right? Something also important to consider is your states of matter, right? We have all gases right here. But let's say, for some reason CO2, or one of these just wasn't gas, right? Well, the problem when that would alter your decision making, right? Because we're talking about pressure, right? And gas is the only one that really affects pressure because aqueous solutions doesn't, right? And we don't really care about solids, right? So that's something else important to consider. Also, the main reason why we were able to find this answer so quickly is because we looked at it and we saw, okay, there's more moles on the product side than the reactant side. Pay attention to your moles in the system given, right? So I'd say the most important things to consider when looking at these problems is number of moles on each side, right? So that's one thing. Then pay attention to the states of matter, right, too. And then look at your delta H just to see if that's going to play a major role. It didn't in this case, but in some other cases, this could be a very important piece of information, Right? It wasn't in this case, but it definitely can be in some instances. So yeah, that's number 8 for chapter 13. Hope this helped, and hopefully I can submit this off my phone.